You've stared at a blank white wall before and seen it. A thin, transparent thread. A tiny bubble, drifting so slowly it barely seems to move. You blink, try to look right at it, and it runs. Vanishes. Then reappears a second later, a little further to the side. It's not dust in your eye. It's not eye strain. And before you go rub your face and forget about it, subscribe, because what this little thing actually is gets a lot weirder in about 30 seconds. Doctors have a name for it, and it's almost poetic. They call it mosquitoes volantes, Latin for flying flies. The nickname fits, because these things behave exactly like an annoying bug that won't leave your face alone. You look straight at them, they dodge. You glance to the side, they follow. For most people, this was just an unexplained annoyance for decades. A strange little speck that showed up out of nowhere, usually in your 30s or 40s, and got more common every year after that. Most people just learned to live with it and stopped paying attention. Doesn't matter if you're in the US, Japan, India, or Brazil, this thing finds everyone the exact same way. But I promise you, there's something hidden here nobody ever told you about. First, forget the word fly. These things aren't flying in front of your face. They're not even outside your eye. They're inside it. The inside of your eyeball is filled with a gel-like substance called the vitreous humor. Floating around inside the gel are microscopic little clumps, fragments of tissue, red blood cells, or tiny protein deposits that formed right there. These clumps aren't alive. They don't have a mind of their own, but they do one very specific thing. They block a bit of the light entering your eye, and that shadow lands directly on your retina, the light-sensitive tissue lining the back of your eye that turns everything you see into an electrical signal for your brain. In other words, you're not looking at an object. You're looking at a shadow. The shadow of a speck of organic matter, projected right in the middle of your own visual system, a shadow puppet show running inside your own eyeball. That already explains the first layer of the mystery. Why does it dodge you the second you try to look at it? Because it's floating inside a fluid that moves right along with your eye. When you chase the speck with your eyes, the gel shifts with it, and the speck keeps drifting, always a half second behind, until it gently bumps against something like an invisible wall. That's not bad luck. That's not a manufacturing defect. That's fluid physics, trapped inside a sealed space. So why do you only notice it sometimes? Here's the second layer. Picture a lamp hanging above a table. Hold your hand close to the table. The shadow comes out sharp. Lift your hand up toward the lamp. The shadow blurs out, almost disappears. That's exactly how it works inside your eye. The closer that speck floats to your retina, the sharper its shadow gets, and the easier it is to notice. There's another detail that makes it worse. When you stare at something flat and uniform, a clear sky, a blank wall, an empty screen, fresh snow, there's no other visual detail competing with that shadow. It's alone out there in the middle of nothing, so it jumps right out at you. And here's the part most people never think about. The brighter the light, the smaller your pupil gets, and a smaller pupil works like swapping a big, diffuse ceiling light for a single pinpoint bulb. Concentrated light throws harder, crisper shadows. On a sunny day, staring at a white sheet of paper, your contracted pupil basically becomes a more efficient shadow projector inside your own eye. Third layer, and this is the one that changes how you see the whole thing. This phenomenon is directly tied to your eye getting older. As the years go by, that vitreous gel loses its consistency, gets thinner and more watery, and slowly pulls away from the back wall of your eye. There's a technical name for it: posterior vitreous detachment. Eye research shows a progression that's honestly kind of wild. By around age 59, roughly a quarter of people already have it. By your 80s, that number is above 80%. If you live long enough, these little specks basically become part of your everyday life. In most cases, this is just a harmless side effect of getting older, and your brain is surprisingly good at ignoring these shadows after a while. It learns to filter them out, the same way it ignores your own nose, which is technically sitting inside your field of vision every second of the day. But there's one exception worth remembering. Studies on patients who notice this detachment happening suddenly show a portion of them end up developing a small tear in the retina along with it. A tear, left alone, can turn into the real emergency, retinal detachment, rare but genuine. Remember this rule of 3. A floater that's always been there, no reason to panic. One new floater on its own, no reason to panic. A sudden shower of brand new floaters along with flashes of light, that's a reason to get to an eye doctor as soon as possible. But that's not the only strange thing you've probably seen in your own eye without knowing what it was. Have you ever noticed tiny, bright, almost see-through dots, darting fast in a zigzag, when you stare up at a clear blue sky? That's a completely different phenomenon, and weirdly enough, it's almost the exact opposite of the first one. While the transparent specks are shadow, these littles are the opposite, tiny windows letting light straight through to your retina. And what's causing that window is even stranger. It's your own white blood cells, moving through the tiny capillaries covering the surface of your retina. A German doctor named Richard Scherer described this scientifically back in 1924, and this effect is still sometimes called the Scherer phenomenon. He discovered that under blue light, you can actually watch your own blood circulating inside your own eye, live, in real time. Here's how it works. A white blood cell is sometimes so large it practically plugs a tiny capillary, opening a small gap of plasma right in front of it. Both that gap and the white blood cell let blue light pass through far more easily than the red blood cells that normally fill those vessels. The result is a bright, tracing the exact path of your capillaries, moving at the speed of your own pulse. Under good conditions, some observers even report a faint dark trail right behind the dot, red cells bunching up in the wake of that one white blood cell. Notice the symmetry here. One phenomenon is dead matter casting a shadow inside a gel. The other is light leaking through because of living cells circulating in real time. Two opposite effects, inside the exact same structure, running the whole time, and you were never formally introduced to either one. Some science museums build entire exhibits around nothing but a blue light screen, specifically so people can see the second phenomenon far more clearly than they ever could just staring at the sky. And scientists actually put this to use. Since the rhythm of those dots follows your pulse, researchers have developed tests that use this exact visual effect to estimate how fast blood is moving through the capillaries in your retina, with zero invasive equipment involved. Maybe the right question was never what is this weird thing floating in my eye? Maybe the right question is how many other biological processes are running inside you right now, quietly, without ever asking for your attention. If you made it this far, you now know something most people on this planet will never stop to figure out. Leave this video liked, subscribe so you don't miss the next time we take apart something you see every single day of your life. And next time that little transparent thread drifts across your view, remember, you're not looking at a glitch. You're literally watching the inner workings of your own eye.